Hey guys, so welcome back to another lesson. Today we're going to go over something called exponential growth. So over the last couple days, we probably should have seen an exponential graph where we talked about if you have this is your four quadrants, your graph will start here. It'll just go something like that. That is going to be off of the function of y is equal to uh, a to the power of x, or we can call that y is equal to a b to the power of x. Um, but today we're going to get a little bit more in depth in the fact that we have a formula. The formula for exponential growth is going to be y is equal to a times the quantity of 1 plus r to the power of x. Okay, so go ahead and write that down real quick. Where a is your initial value or the initial amount that is given to you, usually in the story itself. Sometimes we'll have to figure out the initial value by undoing our function. Next we have r. R will always stand for growth rate or decay. It will always be a percent. And then x is how much time have passed for your model to either grow or decay. So now let's talk about the initial time intervals. Some common words that you will see will be annually. Now that just means once per year. We have quarterly, which means if you're 12 months in a year, split those into quarters, you will have every 3 months. And then we'll have sometimes something called bi-weekly. So the word bi in math would mean every 2, and then or bi-monthly every 2 months. So those are some common time intervals that would pass in our either growth or decay model. Now let's just jump right in. A bacteria question. Bacteria is a very popular question when it comes to growth or decay. So bacteria culture grows at the rate of 20% each day. There are 450 bacteria today. How many will there be? 1 tomorrow, 2 in a week. So since we know this is growth model, we're going to write the formula. Y is equal to a 1 plus, I usually write 1 plus or minus r to the power of x. 1 plus or minus, plus would mean something's growing. Subtraction, that would be a decay or something that's decreasing. So tomorrow, so first thing we need to do is figure out our initial value. So y is equal to, there are 450 bacteria today. So just put that in for a, replace a with 450. 1, there will always be that 1 because that would be considering that 100% of the original amount. Since we're growing, we're going to have plus 20% in decimal value is going to be 2/10 or 0.20, and then to the power of x, but instead of x, I know that it's just 1 day, so I'm going to go ahead and put 1 in right there. This is when you would grab your calculator, and I would just go 450, open parentheses, 1 plus 0.2 to the power of 1 day, or 1 day have passed. So after 1 day, I would have 540 bacteria. Okay, so after 1 day, you will have 540 bacteria. Okay. All right, let's try the second one. In a week, I know that in 1 week we're 7 days. So that means same function, same model. Y is equal to 450 times the quantity of 1 plus 0.2 to the power of 7. And then from here, I will just use my calculator, do the same. Now, if you don't want to put 400, you don't want to do that 1 plus 0.2 to the power of 7 and get that 1612.43 about. You can also, you know that 1 plus 0.2 could be the same as 100% of the original amount. plus 0.2 will be 1.20 or 1.2 to the power of 7, and you can quickly tell that they are the exact same solution or the exact same answer. So it's really up to you what you want to write. A lot of students like to stick to the original model and put that 1 plus in there and see the relationship. Some students just go ahead and combine it. But either way, you'll get the same answer. So in 1 week, you will have about 1,612 and 43 hundredths bacteria, total bacteria. Okay, so there is my function for 1 week, and there's my function for 1 day. So in review, if we're playing with this culture of bacteria, our function would be y is equal to 450 to the 450 times the quantity of 1 plus r to the power of x, or in this case, r would be 0.2, and that will be our equation for this function. Okay, let's try another one. You bought a new television for $700. Each month you own it, the value decreases by 2%. How much is your TV worth after 1 year? So I know that the model for that is going to be y. Same thing, y is equal to a times 1 plus or minus r to the power of x. But I know that this is decreasing, or decreases, therefore it's going to be y is equal to a 1 minus r to the power of x. That means I just find my initial value of 700. Y is equal to 700, which stands for A. 1 minus point, since it's 2%, 2% is going to be 0.02. 0.02 to the power of x, and there's my function, and all I have to do here is replace x every single time with the amount of time that have passed. So x here after 1 year, but what we know is it decreases every month. So there's 12 months in a year. There are 12 months in a year. So we go 1 minus 0.02 to the power of. You get y is equal to 700 times the quantity of 1 minus 0.02 to the power of 12. Now let's talk about what happens when I do this mathematically. 1 minus 0.02 will just be 0.98 to the power of 12, which means every month my television is, if you want to stick with the plus, it's gaining only 98%. Instead of gaining 100% and then some, because that would be growth, it's gaining less than 1, which means it's gaining less than 100%, which means it's slowly decreasing in value. And then from here, I'll just plug it into the calculator, and I get 700. 1 minus 0.02 to the power of 12. And after a year or 12 months, my television is worth about $549.30. Okay, and that's how you would do a decreasing model, or a decay in this case. Again, plus or minus it's the same. You can leave it as plus every single time if you want, but you just have to understand that when you're decreasing, it's got to be less than 1. Okay, we'll do one more. Another popular question is somebody depositing money into a savings account, and then what happens is it accrues interest, and then you get some kickback every year or every so often. So Seth deposits $200 in a savings account. The account pays 5% annual interest, assuming that he makes no more deposits and no withdrawal, calculates his new balance after 10 years. So it gives me the time, it gives me every piece of information that I need to fit into this formula. 200 is my initial value. It's how much I walk up to the counter and put it into my account. I know that I'm going to have 100% of that $200, so that'll be 1 plus 5% is 0.05 to the power of x. This would be going from a formula to an equation, a mathematical model that models Seth's relationship with how much money he puts in and how much he gets back. So all I have to do is replace x with how much time have passed, and we're assuming it's 10 years like it says here. So it's going to be 1 plus 0.05, 10 years to the power of 10. And then there's not much after that. You just go 200, 1 plus 0.05 to the power of 10 for 10 years. And you get after 10 years, Seth would have about $325.77, or if we want to round to the nearest hundreds, $325.78. So after 10 years of putting $200 in and only getting 5% every year and nothing happens, you don't put more money in, you don't take any money out, you've only made about $125.78. It's not very much. And we'll talk about more of a growth model and rates of increase in class. So that's all I have. I just wanted to show you guys how to use the exponential growth or decay function today. Please make sure you guys rewatch it. If there are still questions about the formula, we'll go over it in class. Have a good day, guys.